Hi there. My name is Jessica Barron. I am from the Reilly Center for Science, Technology, and Values, and it is my great pleasure to introduce our next two speakers, Rear Admiral Dr. David Titli and Major General Dr. Robert Latiff. Dr. Titli is the former Deputy Undersecretary for Operations at the National Oceanic and Atmospheric Agency, where he was responsible for day-to-day management of NOAA's national and international operations for oceanic and atmospheric services, research, and coastal and marine stewardship, and served as a key advisor on the NOAA program and NOAA program and policy issues. He has a Master's of Science in Meteorology and Physical Oceanography and a PhD in Meteorology from the Naval Postgraduate School, and he is a Fellow of the American Meteorological Society. For over 30 years, his Navy career included duties such as oceanographer and navigator of the Navy, Director of Task Force Climate Change, and Assistant Chief of Naval Operations for Information Dominance, which is the coolest title I've ever heard. Dr. Titli has also served as the Deputy Undersecretary of Commerce for Operations and the Chief Operating Officer at NOAA. He currently serves on the advisory board of the Center of Climate and Security based in Washington, D.C. Dr. Ledev, who told me to keep his bio short, but I'm not going to because I think it's important that you know how awesome he is. Dr. Ledev is a triple domer who received his commission from the Army ROTC program at the University of Notre Dame. He entered active service in the U.S. Army and later transferred to the U.S. Air Force, from which he retired as a Major General in 2006. He's now a private consultant providing advice on advanced technology matters to corporate and government clients and to universities, and is a member of the board of several high-technology companies. His current work includes a study for the Department of Defense on the ethical implications of emerging and dual-use technologies. While he was in the U.S. Army, General Latiff served both in the Infantry Branch and Ordnance Corps, where he commanded an Army Tactical Nuclear Weapons Unit, and there's really no one I'd rather have in charge of a nuclear weapon than Bob Latiff. He was also an assistant professor of engineering at the U.S. Military Academy at West Point. Dr. Latiff's last active CERT duty assignment was at the National Reconnaissance Office, where he was Director of Advanced Systems and Technology and Deputy Director for Systems Engineering. He also served as the Vice Commander of the USAF Electronic Systems Center and Commander of the NORAD Cheyenne Mountain Operations Center. He is a recipient of the National Intelligence Distinguished Service Medal and the Air Force Distinguished Service Medal. Help me welcome both of our speakers.
Okay, thanks very much. Everybody hear me? I think yes. Good. Okay. Well, I was asked to come to Notre Dame, and this has really been a great honor and a privilege. And I won't repeat all the things that Andy Rosenberg said, because kind of by the time you're in an afternoon of the third day of a three-day conference, it's the saying, I think everything has been said, but not everybody has said it. So I'll try to find a few different things to say. But when I got invited, I was trying to think of, what is there any similarities between my background and here at Notre Dame? And as I mentioned, I went to Penn State as an undergrad. You might have heard of that place. We also kind of have this game that, really big people push each other around in the fall on about 8 Saturdays in our home stadium, and we kind of do that. But I realized we also had another common thing, is we both played for national championships. We both played against Alabama, and we both had the same outcome. Although ours was 14-7, and we had 12 men on the field in the last time, and that was only 34 years ago, so I'm sure all you guys will forget about what happened this January in 3, 4, 5 decades, something like that. So anyways, that's that. We've talked a lot about communications. Day one, and a little bit yesterday, and a bunch more today. The answer is it is one of these all of the aboves. There are lots of different ways to do these. This is one thing put out by Columbia, Truth in Advertising. I have no relationship with Columbia. I don't get paid for advertising their stuff, but it's pretty good. And the reality is it doesn't matter whether it's climate change or just kind of a lot of science. If you go through this thing, it's a pretty good way for how scientists can talk to non-scientists and policymakers. So I guess all of these slides are going to get uploaded there, so you don't need to all write the stuff down, but I've got the link on there. And is a gentleman who asked about why are the meteorologists so slow and so dense about climate change, is he still here? I guess not. Okay. If anybody cares, I'll be happy to address it in the Q&A, but in the interest of time, since that gentleman is not here, I'll keep going. Okay, and I guess that's kind of where we are today here on how we do communications. That was this morning's Calvin and Hobbes on Facebook. Okay, this is what I'll talk about, and I'm going to go through the first part and second part especially kind of quickly because, again, a lot of this has been covered by different people. I've got a little bit different take on some of this, so for what it's worth, we'll put there. I can do messages in terms of threes. We used to have a naval strategy. It was worked on by a year and a half at the Naval War College up in Newport, Rhode Island. The brightest people we could find. We got the smartest civilian thinkers in, and it's a wonderful academic work. But there are 6 components, and and to this day, I have a hard time remembering something with 6, and it's got all these subtleties. It's like power projection versus maritime security versus sea control. Frankly, you can ask like 100 senior officers, and you'll be lucky if you get 3 of them who can actually tell you like what the difference is between those terms. And we were supposed to talk about that to America, whatever that means. It didn't work so well. I mean, it's a great academic piece, but it didn't work so well. New boss comes in. We didn't say it's a new strategy, but he has a different way of talking about 3 things. 3 things. So my wife knows this now for the Navy. $140 billion organization. 3 things, 6 words. Warfighting first. Operate forward, be ready. And that's how that's how the Navy kind of looks at things, including things like climate change, including things like the Arctic. So while the messaging isn't the only thing, simple messages are better than really hard, complex messages. So what are my 3 for climate change and why climate change matters in national security? I argue this is about people and not polar bears per se. One evening I was bored, so I just Googled climate change. Of course, there's 5 billion links that come up, and hit the images. And then I just started counting images as a function of the whole, and almost 1/3 of the images were like polar bear related. Just, I didn't put them there. That's just kind of what Google, and we all know Google's never wrong. So that's what came up on there. And, I think Andy might have mentioned it, one of the Andys this morning. Hey, that's great, but if you're trying to figure out how you make your mortgage, your spouse has just got laid off, you're trying to figure out your health care, and your kid wants to go to college and you don't have the money, where do polar bears come out in that ranking? I mean, in some abstract way, yes, we probably care about them. And then, of course, you get but the polar bear numbers are increasing, so, do I care? And it's like, okay, we're so far off track there. Climate change really is about people. It's about us, it's about our children, it's about our neighbors, it's about our cities, our villages, our towns. So it's really about people and not polar bears. It's about the water. If you can take all this stuff, a common unifying theme on climate change is it's about the water. Too much, too little, wrong place, wrong time. Dry where you thought it was going to be wet, wet where you thought it was going to be dry, salty where you thought it was going to be fresh. It's really frozen or liquid where you thought it was going to be frozen. And it's really about the water. And oh, by the way, if it's about water, that means it's about food. And it also means it's about energy. Our energy is actually, as I think, was it Jenny? I think somebody pointed out earlier today, the energy is actually very highly correlated with water because for much of our conventional power generation, you need large amounts of water to cool it. In the big European heat wave of the mid to late 90s, France, which generates like about 80% of their power from nuclear reactors, they have to shut them down because of low river levels and high temperatures in those rivers. So then they imported power from Germany, who produced it by coal. It's just a perfect irony there. So that's what's going on. And there's not a whole lot of water. I don't know how well this thing shows up, kind of okay. That first bubble, if you will, sphere, it's about 860 miles in diameter, give or take. That's all the water in the world. The next one that sort of looks like over Memphis, that's about, I think, 75 miles. That is all the fresh water, including groundwater. And that little dot over Atlanta that almost looks like it's kind of a screen something, that's the amount of fresh water that we can actually get a hold of. There's not that much. And that's only like about a 30 nautical mile diameter circle, or cube, if you will, sphere, I should say, of water. There's not a whole lot, and that's what we're kind of messing about with. Okay, who remembers, some of you guys do, the 1990s, way back in the day there, in the 1990s. And who were these guys? Clinton, right? President Clinton. Who's the guy on the right? Carville, James Carville. You know, the brains behind the operation there. And what did Carville say about the economy? It's the economy, stupid, right? Yeah. Well, I would say, for national security purposes, it's the change. It's the change of climate change that is the real driver. It's not that our climate today was like perfect or optimal. I mean, it's hot as all get out in the deserts. We have droughts, we have, you know, you go up to the Arctic, you're not ready, you will die. It's really, really cold up there. You know, you go to the Antarctic, you will die. It's not like, you know, every place is like San Diego on the Earth. It isn't. But what it has been is for about 13 or 14,000 years, relative to much of the history of the Earth, it's been amazingly stable. So with that stability, both us, humans, and the natural ecosystem has been able to specialize and being able to really optimize and exploit, in a non-pejorative sense, but basically exploit that stability. And if we start changing, and especially the faster and more abrupt those changes are, and we heard some lectures earlier in this week that the change probably would not be this nice uniform, but abrupt, that then becomes sort of this national security issue of, if you start these big external forcing, how does it play out? And if anybody tells you they know how it plays out, you know they don't know, okay? There's a lot of people who pretend, especially if there's a contract involved and they think there's money in it, they will tell you how it plays out. But the reality is we do a lousy job of forecasting the future. It's hard enough with just nonlinear dynamics, fluid equations. With people, it's really, really hard. But I'll tell you, it's a forcing function that then becomes something which the national security establishment takes very, very seriously, because you can't control it, and it's usually, not always, but usually does not turn out for the better. So 3 things. It's about people, not polar bears. It's about the water, and it's about the change. That's kind of how I look at climate change as related through a national security lens there. Okay, here's my change thing, and I've sort of talked about this. Let me just try to explain this graph here really quickly. At the far right, that's about 60,000 years ago. So really old. Present era, today, right on the bottom left. And all these spiky things, that is not the average of the climate. The higher the spike means the more change, the more unstable, if you will, the climate is. So really high spikes, really massive, massive changes. Really low spikes or very little spikes, very little change. And it's just what I talked about. If you read this book by Nicholas Wade called Before the Dawn, it's a great book, by the way, what you'll learn, what I learned at least, was that our brains, human brains, basically evolved to what we have today about 50,000 years ago. So about 50,000 years ago, people were people, and you know, if you could talk to somebody, you know, the brain is about what we had. But when did we start getting agriculture and civilization? And as soon as we got civilization, we were all starting to carry around iPhones and doing this all the time. It didn't happen until the climate became much more stable. Why was it? Were they too stupid to figure this stuff out? I don't think so. I think one of the things they were trying to do was just simply survive. 1 million or 2 people worldwide were trying to survive. And then when we were finally able to say, okay, last year was kind of like this year and kind of like the next, you can start doing things like planting crops and having some idea that you're going to get a crop back. And that then led to civilizations, and now we all have iPhones. It's not just about climate change. Climate change is certainly one of the things, but Andy Revkin talked about the population. I mean, you know, 7 billion and going up. The oil, the food, the energy, the water. Globalization. So with globalization, it's brought a lot of benefits and a lot of stuff. You know, go to Walmart if you don't believe that. Well, then you can still ask, has it brought us benefits? But it is also, whether we like it or not, made things like flooding in Thailand now really impacts like what we do here. Technology. Technology, again, has connected us in technology. This is a graph of Moore's Law. That continues on. So how we interact with the world, how the world is impacted by us is certainly to a large degree a function of our technology. And that shows no signs of slowing down. And then who's this guy here? That's Jack Lew. Why do I put him up? He is Secretary of the Treasury. Why? Because we're going to deal with all this stuff and we have no money. So we're going to deal with all of this, at least for a while, maybe a longer while, in a very, very financially constrained environment. So that's kind of what we got. I got the three things. It's about that stability. And although we're really talking here about climate change, it's got to be looked at as one of the drivers of these big, big things that's going on in the world. So how do we know what's happening? I've told a couple people in breaks and stuff that one of my most fun jobs in the Navy, this is a long, long time ago, like 30 plus years, is I got to be a navigator on a guided missile destroyer. And this is way before, I mean, you guys in the back won't even believe there was such an era, but this is before the global positioning system even existed. You know, your parents probably told you about that or something. So there was no just look at your iPhone and it's like, oh, okay, I'm there and I write it down and I'm good. So you actually got to, you know, shoot stars and sun lines and all that kind of stuff. One of the things you learned is don't trust any one source of data entirely, but look at a whole lot of stuff and then put it in, you know, what's in between your ears, and you come up with a pretty good feel with a confidence of where you are and where you're going. If you don't or can't do that, then you'll probably be finding yourself, you know, working as a greeter for the nearest Walmart sooner than you might have thought, because bad things happen if you don't put all that stuff together. So sometimes I'm asked, you know, when I was doing this on active duty, you know, my fellow flag officers would come up. It's like, Titli, did you get religion? Can I say this here at Notre Dame? And it's like, well, you know, I kind of went to the church of the radiative transfer equation, because this is really just physics. I mean, and we've heard a little bit about this. In fact, you know, we heard yesterday some of these gentlemen, Fourier on the left, or early 1800s, he figured out that the Earth would be a lot colder without an atmosphere than it is with. Tyndall, you heard about him yesterday. He actually started to figure out that CO2 is a greenhouse gas. Lincoln, he said, you know, hey, when we get really tough problems, you know, and the amazing thing is he did this in year 3 of the Civil War. He had a couple other things on his plate at that point. But he said, you know, when we have really tough problems, let's get some really smart guys and gals together, and they'll go figure it out for us. It's called the National Academy of Sciences. And that Swede, Arnhus, on the right, at the end of the 19th century, actually did some calculations. They were conservative, but he figured out, hey, with the Industrial Revolution, we're actually going to be changing the climate. So again, you know, I don't hear it a whole lot, but sometimes I do. You know, geez, this greenhouse gas, is it even real? Is it, you know, can this even happen? This, ladies and gents, is cutting-edge 19th century science. I mean, the details, yeah, we still got details to work, absolutely. But the basics are, frankly, not only are they known, but they've been known for a long, long time here. Okay, but, you know, as I said, I'm a navigator, so it's like, yeah, I got that, but let me look at some other stuff. Well, let's look at the Arctic. Let's look at what's going on the ice there. And I'll show you another thing here in another slide, I think in 1 or 2, that kind of shows the extent. But this graph on the right, I'll tell you, is a huge, huge change that's going on. The green, this is all the really hard ice, what they call multi-year ice. It's usually 2, 3, 4 meters, so like, you know, whatever, 7, 8, 15 feet thick. It's hard because all the air pockets have basically come out of it. The salt is out of it as well. And this stuff, as you can see, certainly back to the 80s, it was pretty constant in the Arctic. So what you had in the wintertime is you had the Arctic totally frozen, and then in the summer, sort of the edges melted back, and it both basically froze up. So I mean, you know, it sort of was a system that kind of like, think of it as like vibrating on the edges. And that's what it was going on. Now what happened in '07 is between melting, but also, frankly, a bunch of it blew out. It just got pushed out beyond Greenland, this old, hard, multi-year ice, and it hasn't come back. And in fact, more and more is leaving. And that, ladies and gents, is probably one of the biggest changes in the natural world that we've seen, and it's happened in all of our lifetimes, and it happened like that. And it's a massive, massive change. So, you know, it's really hard for me to look at this and say, well, geez, something's not changing here. Here's just something that NOAA put together. It's about, almost 8 years, I guess, of ice looked at kind of almost every day. The white is the really hard ice, that multi-year ice, as I talked about. Here's 04, 2005. Watch what happens here coming in 2007. Boom. And now you see how it just doesn't really come back. And you get these little filaments, and they start breaking up, and they get sort of attacked, if you will, by warmer air and warmer water. And at least up until now, we see no evidence in the Arctic that that ice is coming back. So we've gone from this vibrate at the edges kind of thing to one that now freezes all up in the wintertime, in the fall, and then wham, it comes back. 4 years ago, I told the head of the Navy I thought we would have like no ice up in the Arctic for about a month in the late 2020s. And there were a bunch of guys who basically wanted me to march down to like the nearest place I could take a drug test because I was clearly on, you know, smoking something. Because a lot of people at that point were talking end of the century, middle of the century maybe, and I was saying, hey, 2020s. If anything, I may have been too conservative. That we could actually have maybe, you know, 5 years, 6 years from now, we could start looking at a period of several weeks with basically no ice in the Arctic in the late summer and the fall, and then wham, it comes back here. So this is like opening up an ocean for the first time in 500 years. I mean, the last guy who opened up an ocean for us in the West was Christopher Columbus. So this is a big, big change for the defense establishment in general and for the Navy in particular. And it's just, I'll just let it run till '07 because it's just amazing to watch the changes here in these last 5 or 6 years and how that ice just is not coming back. Okay, if you want to understand climate change, if you're a scientist, I don't know how many scientists we still have here, you got to go to the ocean. It's sort of the Willie Sutton theory. You know, why do you rob banks? It's where the money is. Well, why do you study oceans? It's where the heat is. That's where the heat is. It's about 85 to 90%, depending on how you do the arithmetic, of the heat. It's not in the atmosphere. It's not in the land. It's in the ocean. You know, you just all think of it. When you're boiling your water for your tea or your coffee, you know, think of how much energy you're putting in just to boil that kettle compared to, you know, heating up like your living room or your kitchen of atmosphere. It's one of the great unknowns is how much heat is actually really in the deep ocean, and as we speak, people are trying to figure that out. Sometimes people say, hey, it's all about the sun. You know, sun gets more, heat goes up. And yeah, that's true. These are NASA measurements, and you can see that it tracked fairly well until about maybe 40 years ago. But these are, again, long-term averages of both the sun and both the temperature, and you can see they've kind of split there about 1980. Sea level rise, we've heard a lot about that. There's a lot of different ways to measure it, but you can see it's coming up. It came up about 7 or 8 inches in the last century, and that rate of rise continues to increase even as we're speaking now, and I'll talk a little bit more about that here in a few slides. And just sort of this, if you look at so-called extremes on precipitation, I mean, the details of this, again, this is a NOAA thing that came out of the National Climatic Data Center run by Tom Carl down in Asheville. this is like, you know, days or areas with like more than an inch or an inch and a half in like 24 hours. So, you know, you sort of have some way of saying, okay, objectively, yeah, that's a significant amount of rainfall. And you can see that, again, for the Northeast, how that's been coming up. And if you think about it, as you get this warmer atmosphere, warmer air actually holds more water vapor. You guys, you know, we probably all learned that, you know, in like our high school chemistry classes and physics classes. So warm air holds more water. So when it rains, you have the potential to get more dumped on you in a certain amount of time. So it kind of makes sense. Yeah, it's what the computer models told us we would see, and it's like, and I like the computer models, but I really like seeing it in the observation, because that then means it's starting to get real. So that's all that. So we've heard, who's heard that Sandy was caused by climate change? Yeah, some people have, and you know, I think, frankly, that's a pretty dangerous, for a credible scientist, it's a dangerous way to put it. And I think Revkin kind of talked about that a little bit this morning. The truth is there were some really big hurricanes in the 1930s and in the 19th century that really went and schwacked the technical term, the New England and the Northeast. There have been big hurricanes for, you know, for thousands and tens of thousands of years. But what we can see happening is everybody's heard of the jet stream, right? You know, your TV weather guy at 6 in the evening talks about, well, it's cold because the jet stream went south, right? You know, we've all heard that. And the jet stream does sort of drive, it's sort of the river in which sort of these storm systems, you can think of them as corks in the river, kind of flow along there. And what's happening is the jet stream is in fact weakening. And just like when you have a river that weakens, it tends to start, you know, kind of meandering more. Think of the Platte River. Think of the Snake River, like in the Teton Valley and stuff, you know, kind of flat. So it just does these big bends and like these oxbow bends and stuff like that. We're actually seeing that. So if you're on like the warm side, it's really, really warm. Like March of last year in the East Coast was like super warm. March of this year, we were on the other side of one of those big things, and it was pretty darn cold. Those big bends you can see in the lower left there actually took what was, frankly, a pretty normal hurricane, late season hurricanes. They're not unusual, but it actually got it to do that infamous left hook back into the Northeast rather than normally going harmlessly out to sea. I love that term as a naval officer because then it's my problem. It's like, yeah, harmlessly out to sea. So that's really what's driving it. And again, the physics kind of makes sense because you get warm air at the equator, warm air less dense, so a given amount, it takes more. You go to the poles, it's cold. So you get, it's all squished down here. So think of like that river going from that warm air to the cold. Well, where am I warming the Earth most? At the poles. So that gradient that was going like down like that is now going down like that. Down like that. So not as much, so now it wanders. But why doesn't the air just roll right down from south to north? Because we're rotating. So that whole Coriolis thing, which it's like, man, I hope this guy shuts up about this because nobody really quite understands it. It kind of takes that southward flow and makes it west. Trust me, buy me a beer and I'll explain it all to you after the talk here. Okay, so, you know, I do not look at these as, you know, the drought was climate change or Sandy was climate change. What I do look at it as is to get some of these extreme weather things. Who plays poker? Can I talk about poker at Notre Dame? Am I allowed to? Okay, I am. Good. Okay, oh, good. You know, let's say to get one of these big hurricanes or big major droughts, you need like a full house with aces high, okay? So yeah, you can get them, you know, you get them. But imagine if you had a deck of cards that had 5 aces in it. Yeah, that's my super secret card deck there. It's a little bit easier to get some of these big things. So that's kind of how I look at it. You know, climate change is kind of like slipped another ace in the deck. We're a little bit warmer. We got some more moisture to work with. Storms in general want that temperature contrast. They want moisture. And that gives us some increased odds. Well, wait a second, Titli, you're talking about moisture and all that kind of stuff. How does that apply for the drought? Remember that jet stream doing that loopy-doopy stuff there? So when it kind of locks in, that's what happened last summer here over the Central Plains. Okay, so that's sort of the, some sciencey kind of stuff and some graphs. Let me kind of just show you maybe a little bit more personal, like what some of these big storms look like. That was my house in Mississippi on August the 28th of 2005. And that's what it looked like about a week later. So now I'm not saying that Katrina was climate change, because again, you get big storms on the Gulf. But these are what big storms do. It was about a 9 to 10 meter, so 30 feet, give or take, wall of water that came up my street. Good news is I didn't have much to clean up. I mean, that is what the lot looked like when we got there. It wasn't like, oh, we've been working for a week to clean it up. So when we say we lost our house, we actually have no idea to this day where our house went. We just know we didn't have to deal with it. But that's what this will do. It's pretty dramatic. So as we talked a little bit in the plenary sessions, and I know a lot in some of the sidebars, maybe we're not really living in the places we should be living. Maybe we shouldn't be rebuilding right down on these really highly vulnerable places. I'm very sad to say that Mississippi basically rebuilt just like they were because they could, and they didn't want to change. Okay, so some of the specifics. You can read this, but really the near-term stuff for the Navy is the Arctic. And I think I told you why. It's opening up, it's an ocean, and that is a huge change if you're a maritime organization. The midterm significant part for the Department of Defense is the sea level rise. And there's sort of two pieces to that. One piece is it's going to cost a whole lot of money. It's going to cost tens of billions, hundreds of billions, maybe more, when you start looking at all the infrastructure that is on the coast that we're either going to have to protect, remediate, mitigate, do something with. Because if we don't, it's not just going to be all of a sudden I'm in 5 feet of water, but what you're going to find is you'll find the storm surges will become more frequent that end up doing pretty significant damage. And what we saw in Sandy was, thresholds matter. So we had, what was it? Irene, I guess it was, the previous year, and there was a significant storm surge to that. But it didn't reach like the subway tunnels. So it's like, yeah, okay, yeah, we got a storm surge, okay, sweep up afterwards, and within whatever, 24, 48 hours, basically everything's back together. You go up just a few more feet, and it's like, uh-oh, we got a problem now, because now we flooded out the subways. And now it's a really, really, really big deal. So you got to kind of understand where your thresholds are. Well, if you're the Department of Defense, you own a ton of stuff, infrastructure, on the coastal areas. I actually had somebody say, well, why did the Navy care so much about all this coastal infrastructure? I said, well, it's kind of a ship thing. It's a lot harder to take your ships and put them in like Albuquerque than it is maybe airplanes or something like that. Ships tend to be at sea level, and if sea level's changing, then this is going to be an issue for us. And then some of these wild cards are things that, the last two, frankly, when I brought them up to my bosses in the Office of the Secretary of Defense, they basically said, Titli, shut up, we just don't even want to think about these things. They said it a little bit nicer, but not a whole lot nicer. The acidification, I kind of look at this as the unsung evil twin, if you will, of the global warming. We all talk about the global warming. Some people talk about, well, geez, if we put like kind of a blanket of aerosols up, we can slow the temperature rise. But again, very well established, non-controversial, it's just physics. And we got a really great lecture on this, I think on Monday afternoon, that as you put the CO2 in the air, you tend to acidify the water. Why do I care? Again, it's not polar bears, it's people. I care because it really messes up the bottom of the food chain. All the crabs and the crustaceans and stuff like that, they have a harder time forming their shells. Do I care about them? Well, sort of, What I really care about is the upper parts of the food chain where the people feed on, because 2.5 to 3 billion, depending on who you believe, people get their primary protein out of the ocean. And if you screw up that food chain, where are they in that 7 billion world going to get their protein from? And especially if agriculture itself is under more stress there. Okay, Arctic, again, you can kind of look through this. This is yet another place in which anybody who tells you they know how the whole Arctic scenario is going to play out, they don't know. And I'll just give you one example. And this is one in which, again, it's sort of a $10 billion bet. And there are big players that are both credible on both sides of this bet. The issue is not so much, frankly, the Northwest Passage. You know, you sometimes hear about that. You read about it in high school and stuff. It's not going to be a trade route. You know, think of the Northwest Passage. When you hear Northwest Passage, think Route 66. Well, how much trade in the U.S. is on Route 66? Well, they took it away, so there's not much now. It's Interstate 40, right? Okay, that's what we really have now. Northwest Passage, it's got some pretty shallow points. It's got some really tricky navigation pieces. And oh, by the way, it'll be one of the last places in general where the ice hangs. And again, happy to talk about that offline if you're interested. The Russians will work on trying to monetize or make profitable what they call the Northern Sea Route. And that's basically a route, think of like starting off from Scandinavia, like from the top of Norway, and just going right across the top of Russia, and then coming down through the Bering Strait and into, into Japan, China, Southeast Asia. They are working hard at that. They got a bunch of icebreakers to sort of keep it free. And not only, bulk materials, oil, natural gas, so they're working on that. The real wild card in all this trade stuff is, are we going to, in fact, establish basically an over-the-top route so that you could go, let's say, from the Pacific, right here, but not this around, but get rid of this ice, and you pop out at Iceland on the other side. And there are some senior vice presidents of some of the major shipping companies. I was just on a panel with them a couple weeks ago. They said, no how, no way, not going to happen, full stop, end of discussion, can we go to the bar now? And they said, it's just not going to be economical. Here's my spreadsheet. Here's my cost per what they call TEU, basically those container things that you see everywhere. And we can't make this work. And by the time we can make it work, we won't even be in business because there'll be some other way of moving stuff. That's one side. The other side is, where the most active area of research and thought is about the Arctic in the world right now is? Singapore, on the equator. Why is that? Because they live, breathe, eat shipping and transportation and logistics. There's a lot of smart money there that really thinks there's something to this, as in Korea, as in Japan, as in China. So I don't know who's right. You got some very credible shippers saying it's not going to happen, but you got some pretty big countries with pretty deep pockets and pretty smart people that says it will. So from a national security perspective, like as the U.S., advising the Navy, it's like, we need to think about this, and maybe there won't be something there, but there very well could be. And if there could be, can you imagine being the head of the Navy in the year, let's say 2035, turning around to whomever the president is? And the president's going to be sort of not much older than you guys. And the president's going to say, I've been hearing about the Arctic and climate change for my whole life. And you, Navy, are telling me that you guys haven't actually thought about this? Do you want to be that guy in charge? That would be a really bad conversation to be in the White House. So the Navy is looking at this today. And it's not that we think we're going to fight a war up there. We think the potential for conflict is very, very low, very low. But just the ability to do basic patrolling, basic presence counts. And that means you need ships that can work up there. That means you need communications. That means you need logistics. It frankly means that you need sailors who have some degree of familiarity with working in what is still a very harsh and very hostile, and it's going to be that way, environment. There just isn't a whole lot there. So in the interest of time, I'll move on. But But, you know, this is one thing we're looking at. We'll look at, you know, you look at the, I've talked about that. You look at the Bering Strait. You know, this is the Bering Strait. And right now, it's not really thought of very much. But if you start getting both oil flowing through there or hydrocarbon resources coming out, and you have trade going through in both ways, it goes from a place nobody thinks of too much to potentially one of the strategic waterways in the world, bordered by the US and Russia. So it's kind of interesting. Okay, just as a little sidebar, those two little dots in the middle, does anybody know who they are or what those islands are? The right one is Little Diomede Island, and that's owned by the US. And the big one on the left is Big Diomede Island, owned by Russia. So, if you stand on Little Diomede Island and look west on the 3 days that it's clear, you can, in fact, see Russia from Alaska. just saying you can actually do that. Okay, sea level rise. We've talked a bunch about this today. I've already talked some, but you know, again, just it turns out that sea level rise isn't just figuring out the average, what's coming up, and that's hard enough to do, but just to give you an idea of where the stuff is that we're going to have to pay attention to, look at the darkest red. The darkest red is sort of like this century kind of issues. And this century, you know, in ballpark terms, think about 3 feet. You know, I could be wrong. There's a big fat tail. If I'm wrong, I'm probably wrong on the low side, but I could be a little too aggressive. So look at the darkest red there. You know, so that's why I need to sell that place that I showed you in Waveland, Mississippi, before I talk too much more about this whole sea level rise thing. If you're buying in the Keys, think about it. Norfolk, unfortunately, Norfolk's in a place that's really low, and it's got a couple other things working against it too. But it's not just the U.S. infrastructure. You have the, which is I think pretty well known, Bangladesh, very low lying. So they're going to have issues. Where do you, over time, it's not like, again, you wake up tomorrow and you find 5 feet of water in your house, but over time, over decades, how do we do this so that it's orderly? Ideally, how do we do this so that this is looked at as a common threat that could, in fact, unite people who may otherwise not have a whole lot in common to talk about? But if it doesn't go well, it could actually be divisive. Any idea where this place is? A little island called Diego Garcia. It's out in the middle of the Indian Ocean. It's actually technically owned by the British. I guess more than technically, they do own it. British Indian Ocean territories, but it's like 99-point-something% used by the United States military. Communications node, logistics node. So if you want a place to fly United States Air Force aircraft from, it's a really good base for that for long range. If you want a place to move supplies into and then keep your ships going, it's a really good place. And oh, by the way, it's only about 2 to 3 feet above sea level. So if you lose that, you then have to think about, well, where else are you going to have reliable logistics in the middle of an area that will probably be still pretty important to us? Okay, I think we all know this famous Irish American here, right, on the right there, Tip O'Neill, and he said, of course, politics is local. That's how I look at sea level rise, too, because it turns out there are 3 components. You got that global part, which is, you know, ultimately, you know, how much ice is going to, in the next few decades, how much ice is going to come off Greenland into West Antarctica? It's a great question, but as I said, if I had to come up with something 3 feet plus or minus. But then you've actually got, and the details count here because it's going to be tens of billions of dollars that you're going to invest, and when is it that you have to invest them? There's a local effect. And it turns out that the currents, the big ocean currents in the world actually either raise or depress the sea level. And just in bad luck for Norfolk, it looks like the ocean currents will slow down, which will actually raise the local sea level for Norfolk as well as the global. And if that wasn't bad enough for those guys, the land, for reasons that has nothing to do with climate change at all, it's actually a result of the last ice age, is sinking. Isostatic changes there. So you got the land going down, you got the local effects coming up, and you got the global effects coming up. So in Norfolk, you got a problem. Norfolk, Langley Air Force Base, Coast Guard headquarters, Navy headquarters, some Army installations, NASA stuff there. It's going to be a big deal for the US government. Okay, fish. I've talked a little bit about acidification. This is if you take acidification and if you take temperature and you sort of run it through a biological model, take it with large grains of salt, but sort of red in general, bad, blue, okay. So it's like, you know, you look at us, and you know, since it's all about us first, you look around the US, it's like, well, this isn't such a big deal for the next few decades, and that's probably true. But if you look at, let's say, the tropical Pacific, there's a lot of places with a lot of red. And you think about the geography out there, you've got a bunch of countries that are not much more than little atolls, and what do they have for their resources? They got 200 nautical mile, what they call exclusive economic zone. Basically, they can fish there and they can decide who else gets to fish and charge them or do whatever they want to. And that's your resource. And if you're sort of in that big red in there, well, your one thing that you kind of had is sort of going. So what are you going to do? Well, one of the things you might do is say, you know, this whole UN Convention on the Law of the Sea that gave me that 200 miles, but only that, well, maybe we need to sit down and like think about this again, because maybe this ain't working so well for us anymore. Now, a little pop quiz. Can anybody tell me what the following countries have in common? See, I can do this now, I'm retired. Iran, North Korea, Syria, Libya, and the United States. It's a great group, isn't it? Yeah. We are the countries that have not yet acceded or ratified to the UN Convention on the Law of the Sea. So if the rest of the world, which is most of the world, decides that it wants to go and modify the terms of that treaty, we don't even have a seat at the table. And the irony is it was written in the 1970s by US maritime lawyers to, in fact, lock in United States interest. You just got to love it. I mean, if you sold this script to a movie, they would reject it because nobody would believe this stuff. So that's going to be an issue. The good news is getting us to ratify this does not cost one dime of money from the Treasury. It does cost some political capital. Okay, so just briefly, what is the Defense Department doing? And I really appreciated following Jenny's stuff because Jenny talked about, you know, 50% is process. You know, and God love the Department of Defense, $500 billion, give or take, organization. You know, if we have anything there, we got process. So one of the ways that you drive process is you drive process through boring things like roadmaps. You drive it through something called the Quadrennial Defense Report. You drive it through something called the Defense Science Board. You know, none of which sounds particularly exciting. It isn't. And if you read all that stuff, you'll see, yeah, climate change is in there, and there's some fairly good recommendations, but nothing that, my guess is here, if we sat down for a day, we could come up with 90% of what's in this stuff. It's not revolutionary. But the good thing is it's out there. And as process, you say, well, geez, is anyone going to do anything about it? Well, the even better thing is not only is it out there, but it's public, and that means that my friends on the Hill also know it's out there. So like in the upcoming budget hearings that will be coming up very shortly, the President, as you probably know, just put his budget out this afternoon. My guess is the Secretary of Defense is going to get asked either informally before the hearing or in the hearing itself, so, Mr. Secretary, how you doing on that Defense Science Board report? How's it coming? How are the recommendations coming? So again, not really exciting stuff, but this is kind of how progress in a lot of bureaucracy is made. And you know, again, a $500 billion agency, it has a lot of mass to it. So as it starts doing stuff, it provides then kind of top cover as well as you know, just simple initiative and inertia in a good way to get other people to do it. So that's why I talk about these. As I said, yeah, it's a bunch of paperwork, but it's actually, believe it or not, important paperwork. Another study came out, again, Naval Studies Board. It's hooked into the National Academy. So again, it's that credible group of people. You know, you guys could have come up with this probably just listening to what I talked about. But again, it's like, okay, guys, it's not just like this wild-eyed oceanographer Titli saying, hey, Navy, we got to do this. It's like, okay, now I got kind of the pros from Dover saying, yeah, this is what we need to do as well. They're not the only ones working this. What I can tell you, I won't put on the slide, but I will tell you, is these two reports, and they're both very good, were sponsored by the Central Intelligence Agency. They don't really have their name on them, although if you look through the fine print, you will find those guys. But the one on the left actually came out of Harvard, Mike McElroy, and the one on the right is from Columbia. And they're both very good. The one on the left, if you want to look at sort of science and even science for non-scientists, it's really good. The one on the right kind of tries to make these links between, okay, so what is it you mean about climate change? And when you say accelerant to instability, what do you mean? And these two reports kind of address those components. In the interest of time, I'm not going to go through these. I mean, that could be like a lecture in and of itself. But sort of the summary of these is the links. It's not like a one-to-one link. It is usually a series of things through kind of either political processes or fragile political states. And the climate, if you will, or some climate forcing kind of becomes that, proverbial straw that tips you into another state there. But if you're interested in sort of that ties, I got the reference at the bottom, and it's actually pretty good. One thing that's tangible, this is sort of, I hate the phrase low-hanging fruit and outside the box and all those, so I won't use those phrases, but one thing that we're doing is, despite all the nonsense of sequestration and all that sort of thing, is the United States needs to basically get better at their weather models. And post-Sandy, I mean, it's just amazing. This geekiest of the geek stuff, weather models. I mean, I thought it was myself and 3 other people in the US were the only ones who cared. But now it's like you can read any blog and they talk about this and that and all that. And some of it's right, but that's okay. So about 2 years ago, we started laying the groundwork, we, the Navy, with NOAA, with NASA, and with, well, you can see the logos there of some of the other agencies. Turns out that the United States has about 5 or 6 that I know of. I'll call them B+ weather models. The Europeans have 1A weather model. We could, if we just took the money we put in today, we could beat the Europeans in 5 years. Easy. And I could actually write a check back to the Office of Management and Budget with the savings. But we don't do it that way because we got every agency doing their own thing. And when you ask an agency, they'll say, yeah, well, my mission's a little different than their mission. And on a narrow technical basis, it is. What they need is somebody with a little bit of leadership and a size 14 boot in the right agency, and you could fix this. But it's one of these sort of things in which, it's big enough that it now makes the blogosphere, but it's not big enough that compared to the multi-billion-dollar issues that the White House deals with. So it sort of falls into that nether region where there's supposed to be adult behavior in the federal agencies. And on Monday, Wednesday, and Friday, maybe there is, but let's not talk about Tuesday and Thursday. Anyways, this is now funded. It's part of the, it's got funded actually in the bill that the Congress passed a few weeks ago, funding fiscal year 13. And there's enough money in the Navy's part to be a serious partner, but intentionally not enough to do it all. So my vision is we get the labs, this is more a hallucination than a vision, but we get the laboratories to play with each other. Now, of course, every lab, when you go to them, they say, this is a great idea, and don't you know I have the smartest people in the US, so if you would just give me more money, I could do it all myself. And we've got to get beyond that thinking. We have got to have a way for labs to cooperate with each other and not kill themselves bureaucratically in the process. And that's a challenge. But this is a good unifying way to do it. Okay, I'll just wrap up here. Remember the floods in Thailand there? What that impacted amongst other things? Disk drives. All our thumb drives, all our disk drives. So yeah, it's like, okay, it may have messed up a few temples and things, but it really, because of the globalization, it tends to impact that. The whole water issues, I think it was brought up earlier this week, some of the engineering projects that are going on in China, on the Mekong and on some of the other major rivers. And sometimes there has been talks with the downstream countries, and sometimes there really hasn't been. So how this water and this competition for resources plays out, again, it could be used as a unifying theme, common enemy, if you will, or common challenge. to work on. Or, you know, it can go sort of the other way in the game theory of what's mine is mine and what's yours is mine. And that can then actually accelerate instability. Okay, in the DoD, we don't have popes or a pope, but we sort of have cardinals, if you will, except we don't call them that. We call them combatant commanders. And I don't know if this is true for cardinals or not, but all combatant commanders are not created equal. Some are certainly more powerful than others, even although they all are 4 stars, and like to the outside, they all probably look the same. You know, but some of them, it's like, okay, they talk about climate change. Nobody will say this. I will because I'm retired. But there, a lot of the sort of traditional defense establishments said, well, of course they're going to talk about climate change. They don't really have that much to do. Well, this guy here, Sam Locklear, he is the head of the United States Pacific Command. And within the pantheon and the hierarchy of combatant commanders, if he's not number 1, he's 1A. You know, maybe the central commander guy would also say, hey, I'm kind of up there too. Europeans close, but not quite there, and then you sort of got the others as far as the geographic. So Admiral Locklear at the, actually it was March 8th. March 8th in the Boston Globe was asked, so what's the biggest threat, Admiral, in your area of responsibility? And again, he's got China. He's got the South China Sea. He's got Korea, Little Kim, you know, all that stuff out there. What he said is, you know, it's really climate change. It's climate change. It's the sea level rise. It's the competition for water. He said, that is my biggest long-term challenge. So again, that's not like some retired 2-star oceanographer. It's like, yeah, you're sort of in the club, but, you know, but yeah, sort of. It's not even some of the combatant commanders who have said this before, but they say, yeah, but you don't own like the Pacific or the Middle East where we really care about. This is the guy who owns the Pacific. The president has had his Pacific pivot strategy. So this is kind of like the #1 guy. And to me, that is huge. So again, it's like, is that an opportunity? Absolutely, because this mainstreams the issue. And when you mainstream a $500 billion organization, that's kind of a big deal. I just put these up, just read the bottom, safe, stable, and secure. The only reason I put that up is when you look at the individual countries in the Arctic and their strategic objectives, you'll see 2 of those 3 words in just about everybody's, including Russia's. So when I say low conflict, there's tremendous, tremendous overlap in everybody's strategic objectives. So it's not just being Pollyannish, but it's being, this is where the interests are. There are still surprises. We still are trying to figure out these things called aerosols. We heard a great talk on that earlier. Some help as far as cool the climate, some, but they do other nasty things like air pollution, lung disease, stuff like that. Some actually accelerate. I mentioned the deep oceans. We really don't know what is going on and how the heat is being distributed. And this thing at the bottom left here, there's something called geoengineering, intentional man-made climate mitigation, like put a whole bunch of, like simulate volcanoes and put a whole bunch of aerosols up, let's say 100,000 feet. Yes, you will cool. What it's going to do to rainfall is an open question, and there's sort of the debating models even as we speak. I can find stuff that just come out within the last week of it's going to, you know, make Africa a drought, it's going to, you know, dry out the rainforest. We don't know. We just don't know. And this is a really contentious part. There is no governance. So I've asked, like, you know, sometimes it's like, well, in the DoD, hey, if another country did this, just did this, what would we do? Would we join them? Would we shoot their rockets down? Would we demarche them? Would we ignore it? And I just get one of those, hey, I'm really busy, Titli, can't you leave now? And like not ask these kind of questions. But it's going to be something we're going to have to figure out there. And the guy on the right, anyone know who he is? Niels Bohr. He has one of my favorite quotes. He says that you know, predictions are tough, especially when they're about the future. So the only surprise I would have in climate science is if there were no more surprises, and I don't think I'm going to be surprised. So the details and how things work, it is an incredibly complex system, and we should not get arrogant that we know more than we think. So I've heard some things about regional modeling, downscaling. it scares the bejesus out of me, okay? Because if your big models have fundamental disagreements, and they do, like between the British and the National Center for Atmospheric Research, and they're both really good models, I don't know which is right. But if you just go and take one of those and then run it and run it and run it, yeah, you can get really fine, really accurate, really wrong answers. So just be careful. When somebody sells you downscaled model predictions, my recommendation is run, not walk away. So be careful on that. We just need to remember this is a really big, complicated system, and we're probably not as smart as we think we are. Okay, I've talked about this. I think it's the change. And Burroughs, you know, he has this quote, "The worst matters much more than the bad." So when we're prioritizing, how do we make sure that we avoid the worst there? A few books, some of which have been mentioned earlier. Nate Silver, a number of you have heard. I like this because he thinks the weather guys are pretty good and everybody else is idiots, so I like it. But he talks about how you should look at signals versus noises and how you watch that. We've mentioned merchants of doubt. It's a component. It's not the only, but it is a component. And if you want to know about how people think and think about risk, Dan Kahneman's book, Thinking Fast, Thinking Slow, is fascinating. It's not a really easy read, but it's worth it. If you can make it through, it's really good, and it'll tell you how we think about things. And again, there's been certainly other folks talking about that, but that's just one I like. Okay. I have this gentleman up here. One of Winston Churchill's many quotes was, "Americans can always be counted upon to do the right thing after exhausting every other possibility." So I would argue that maybe we're in the process right now of exhausting possibilities, but eventually we'll get there. If you don't like a Brit, you can have this rather famous gentleman who said that, you know, life is tough, but it's tougher if you're stupid. So we will get there. This is kind of how I think we're going to end up doing this, thanks to Tom Hanks producing this. You know, Apollo 13 was a somewhat near miss there, but at the end we figured out we really did have a problem. We may not have had the right tools, but we pulled together, we formed a team, and we figured it out, and we avoided the worst. We didn't get to the moon, but we avoided the worst. We saved those guys, and I think that's... I'm just fundamentally long-term, I am optimistic that we will get there, although how we get there is probably a rocky road. And for this conference in particular, you may or may not have seen this cartoon before, but you know, there's a bunch of benefits that we can get to, and we've heard of both on Monday and today. There's a bunch of things we can kind of work on that, oh, by the way, will get to the climate mitigation without ever having to utter those two words and then go through all the, you know, sticking your hand in that 440-volt socket there. So with that, that's USS Connecticut coming up through the ice. It was really interesting doing that because they said if you start feeling the ice really like crumbling around you, run in this direction. But fortunately, we weren't that close, so it was okay. And with that, I'll thank you very much. So you are here. Okay.
So yes, I did ask Jessica to make my intro a little short because I'm just asking questions. So Dave, one or two questions for you, and then I'll open it up to the rest of the audience. I had the opportunity to talk to Admiral Titli about how he got into the job he got into. And it had to do with some leadership on the part of the Navy. I think it was the Chief of Naval Operations who recognized this as a problem. So very inspiring. You mentioned the CIA. As you know, as many of you know, the CIA had a very active climate change program until about last fall, I think, wasn't it?
It's been up and down.
Okay.
It's been up and down.
Basically, it was killed under some pressure by Congress. So when you mentioned the fact that you thought that the Chief of Naval Operations would be asked what he's doing, or the Secretary of Defense, I actually had a different approach that I'm wondering, maybe you can comment on the fact that do you think in this Congress maybe even the things that DOD and Navy are doing will suffer?
Okay, so it's a great question, Bob, and I'll look at that as, one of the things that the Navy's doing that I didn't talk about here is the Secretary of the Navy, Ray Mabus, has made one of his top three, and he's back to three things, energy. And he has been focused on that since day one. The House of Representatives tried to kill that. Secretary Mabus has sufficient both backing from the White House and political skills of his own. He's a former governor. He was basically able to do an end run, and the House voted to keep the money. So I think with leadership and with savvy leadership, you can't, if DC's your first time you've ever done politics and you're in an agency head, it's going to be tough, and I've seen that happen. But with savvy leadership and backing, you can still work this. So you mentioned Admiral Roughhead. We had, of course, the election in fall of 2010. A lot of politics changed inside the Beltway. I told my boss, Admiral Roughhead, it's like, hey, sir, I got the Navy pretty far out here on this whole Arctic climate change thing. Are you okay with that? And he was a former head of our legislative affairs, so I mean, he knew the hill. And he said, yeah, Titli, this is okay. I'm comfortable with where we are. I mean, again, it would have been easy to retreat, but it comes down to, frankly, it comes down to leadership.
My last question, and then I'll open it up. You referenced a lot of reports. There are other good reports, the Global Trends 2030 document, the Harvard reports, the National Academies, all great recommendations, and it looks like the Navy and the DOD are doing some things. The question I have is, those are things that will help in helping surveillance and monitoring and being prepared for these things. Is there any role in your mind that the DOD can play in trying to push forward the larger question of how do we actually put a stop to this?
Yeah, I think. Yeah, I think I'm back on. I think there is, and again, this really is the energy part. So there was a sister task force. I ran task force on climate change. There is also a task force on energy. So literally the first thing I did when I got out of the meeting that stood up the climate change one is found my counterpart, two-star, and thank God I knew him from other jobs, and said, Phil, you and I are two sides of the same coin here. Now, we never said that when we went to the Hill, because if we had tied energy to climate change, it would have probably been killed. So there's ways in which we sold the energy externally. We talked about security. We talked about the cost of getting a gallon of diesel to the Marines in Afghanistan, how many lives it was, not to mention just the dollar value. We talked about tactical flexibility by using energy more wisely. But we all knew, and we would talk about it inside the Pentagon, that it's a huge mitigation to the global greenhouse gases. Now, if the politics change and flip, of course, you can talk about that more publicly. So, the counterexample is look at NOAA with climate services. NOAA sort of did the, hey, let's go run into the wall in post-2010 and show how much of my budget is climate services. And what they got for that was a near-death experience. The House voted to kill about half of NOAA, as it was the final appropriations and law took 20% of all NOAA research, and they lost it, and it's gone. So you can't be stupid, but there are ways, if you understand, I think Jenny mentioned, begin, and Covey mentions, begin with the end in mind, understand your objective, and understand there are many, many different pathways. It's sort of the, if you can't get them for murder, get them for tax evasion.
I will forego all of my other questions and open it up to the...
I know on time, what would you... Happy to do whatever you want. 3 minutes of questions if there are. Okay, we have 180 seconds of questions.
All right. So I'm not a climatologist, but you had mentioned, but I am a concerned citizen. You mentioned earlier that you'd probably avoid saying Sandy was caused by climate change, but I think that my research has indicated that in probably the past decade has been much more active in cyclones and tropical storms than probably the past 150 years. No? Is
No.
that not correct at all?
No. Take a look at accumulated, I mean, okay, we can have this debate if we want.
Well, I don't want to debate.
Look at accumulated cyclone energy. Just Google accumulated cyclone energy. So when you're looking globally, you'll see we're at about a 35-year minimum right now, and that is a numbers times size times intensity in kilojoules.
Okay. Well, thank you very much.
Okay.
Shall I go ahead? Or go ahead. Go here. So I'd like to know, at the beginning of your talk and earlier today, that gentleman had asked why there were not more meteorologists in the field of climatology. So I'd like to know the answer to that.
I asked if any, you must have been gone, because I asked who asked that question and nobody raised their hand.
I apologize. I just got back from class.
Okay, all right, okay. Well, it's good you're not skipping class there. Okay, we won't talk about my undergraduate experience. Here's the reason. There's a little bit of ideology, but you know there's ideology in every single group. Where weather guys, and I was one for like 40 years, you live and die by the numerical forecast models, by the computer models. And what you understand as a weather person is after day 2 or day 3, the skill starts going down. Some highly predictable events, yeah, you're good till day 10, maybe. A lot of times by day 3, day 4, the models aren't worth a whole lot. So if all you're doing is day-to-day weather forecasting, sort of at that tactical weed level, like do the big thunderstorms come through South Bend at 8 in the morning or at 2 in the afternoon? You know, if your model said, well, geez, they weren't coming through till this afternoon, it's like, but they came through this morning. It's like, well, this is a piece of garbage, so it's worthless. So it's easy to see the logic. It's like, hey, if I can't trust this thing beyond 3 days, or sometimes shorter than that, now you're telling me to trust this same model, and it basically is the same model. It's the same fundamental 6 equations of motion. You know, out at 30 years, what the meteorologists are missing is that today's weather is driven by basically what was going on yesterday. So you got to have the observations, and for anybody who's a physical scientist or engineer, it's the initial conditions. It's driven by initial conditions. The climate could care less about what the weather was in South Bend yesterday. It cares about what it is for the big, like the gazintas and the gozoutas. How much energy is coming into the sun? What is the land-sea distribution? How much energy is being kept and trapped by the atmosphere? That drives the climate models. So that's, in sort of technical terms, that's the boundary conditions. The meteorologists, by and large, don't really get that until you explain it to them. So I went actually to Boston to talk to the American Meteorological Society Broadcasters Conference, and we talked about just this. And it was like, oh, now I get it. So there is a... It's not just some vast conspiracy or something. There is, to a large extent, an education issue. Yeah, there are a couple guys, John Coleman, that I'll probably never convince. But a large majority simply don't think in terms of the difference between, observations and weather today versus long-term forcing. That's what the difference is.
Okay, you have questions, but you're welcome to buy them.
Okay.